All right, everybody. Today we are going to look at our last method of factoring, and you can hear my dog. It's now 7 o'clock at night, and she still barks like crazy. So if you're in class, you can hear it, and you can hear it now when I make movies. Uh, so here's what we've covered in this section, or this whole section 4.4. We've talked about GCF extensively. That is done every single time. Then we've worked at trinomials. We worked at them when a was equal to 1, and then we also worked at them when a was not equal to 1. Just a reminder, when a was equal to 1, we wrote down c and found r and s that would multiply to give us c. And then when a was not equal to 1, we had to use ac, the multiplication of a times c to get our number, and then we had to go hunt down what r and s were. Then just the other day, we worked with the difference of squares, the difference of cubes, and the sum of cubes. I'm assuming in class this Friday, tomorrow, that you will have some questions about those three factorizations. We have one more special one, okay? And he's kind of off to the side because he's really the only one left, kind of, okay? So here is our decision tree for how we factor any polynomial that we're given. Okay, the first thing we always do is we check for a GCF. We want to make our numbers as small as possible and take out any extra variables and bring those out to the front. So this is going to be done every single time. Then, if it's only a two-term polynomial, then you're going to use one of these methods we talked about yesterday. Okay, if it has three terms, then we undistribute. Now this is the RS method that we talked about. R times S has to equal C, or R times S has to equal AC. And this is if A does not equal 0. Okay? Or not equal 1, sorry. And the other one is if A equals 1. Okay, so we have those two different ones to look at. Then our last one, the one we're going to look at today, and this one actually most students tend to like. This is when we get a four-term polynomial. And it's called factoring by grouping. Okay, so we're going to take a look at a couple of those. This won't take very long, not like yesterday's for certain. Bag of problems. You always want to do this first. Make sure it's in standard form, of course, and I think they probably all are. But you got to do this first. Always look for a greatest common factor first. If you have two terms, then you're going to be working through those special ones we looked at on Thursday. If you have three terms, you're going to try and do that R times S. And if you have four terms, you're going to try this regrouping that we just looked at. So if we kind of look at it big picture, there's only three different factorizations we have: two-term, three-term, and four terms. Now, unfortunately, in that two-term category, we do have three things we have to memorize. All right, that should take care of us. Good luck on your homework. Try to get everything in, please, by Friday night or Saturday morning sometime, so I can get everything graded before Sunday and uploaded to Skyward. So here we have a big polynomial, but it's got four terms, and you would check to see if you could combine any of these, but you can't because this is the cubic term, this is a squared term, this is a z to the first power term called a linear term, and this is a constant. So remember, to add them, they'd have to have exactly the same variable, but also the same exponents on them. And none of those have common exponents, so we can't add them. Now, when you factor by grouping, you have to think of, in general, it's not always the case, but you think of the first two terms as one group and the second two terms as another group, okay? And so I'm going to rewrite this as a z cubed plus 5z squared. There's my first group. I'm going to put it in parentheses. I'm going to put a plus sign, and my second group is going to be negative 4z minus 20. And this is why it's called factoring by grouping. because I've grouped them into these two groups. And this doesn't always work with 4 terms, but since that's what we're practicing, you'll probably have pretty good success with it. And I'm going to, let's get another color here. There we are. Now, what you do next, after you've grouped the first two and the last two, I'm going to highlight this first pair. You look for a GCF just in that pair. And we can see that we got a z cubed and a z squared, so they have a z squared in common, so we're going to factor that out. Leaving us with, we took away 2 of the z's, so it's just z, and we took away the 2 z's of the z squared next to the 5, so it's just 5. Then we do the exact same thing. We look for a GCF in the second grouping. In this case, everybody's divisible by -4. So we're going to pull that -4 out, and we'll be left with z plus 5. Notice what we're left with in both of these. And this is what we want to happen, and we hope happens. Okay? Now, I'm going to, you don't have to do this, okay? But I'm going to show you what you're doing, and then I'll show you how to do it without doing this extra step. And the step I'm going to do is I'm going to just make up what we call a dummy variable. And I'm just going to say, let a equal whatever this common thing is, z plus 5. And if I do that, I can rewrite this little equation as z times, there's z plus 5, so that's now a. And this is -4 times z plus 5, that's a. Look at how that a is a common factor of the first term and the second term. So I could factor that a out, leaving me with z squared minus 4. But it's not really an a there. A represents z plus 5. So this really represents z plus 5 times a z squared minus 4. Okay, so that's what we call using a dummy variable. Now, in practice, you don't have to do this. What you have to do is recognize that in this first multiplication out front, these are multiplied together, and z plus 5 is a factor of that first term. And in the second term, z plus 5 is a factor there. So what you do is you GCF out z plus 5, and you're left with a z squared minus 4. And we didn't have to use a dummy variable. Okay, so we undistributed the whole group. The group was z plus 5. Now, unfortunately, we're not quite done with this problem. And the reason we're not done is because we're very observant, and we notice we have a z squared, a minus sign, and a 4. And z squared and 4 are both perfect squares. So we can continue to factor this. Okay, think of this as a z quantity squared minus a 2 squared, and we're left with z plus 5. And remember the difference of squares. A, that's my a, that's my b, a minus b, and a plus b. And that would be a complete factorization of this 4-term polynomial. It won't always be the case that that thing you're left with, z squared minus 4, is a difference of squares. That won't always happen. Sometimes you'll be done as soon as you do that GCF with the binomial z plus 5. We've got a couple more examples here. Let's take a look at this 4-term one. Okay, and I'm just going to group the first two. Plus 4x. Notice how when I group them, I capture the minus sign in the second one. You want to make sure if that's a minus sign, you got to grab it. Okay. Now we GCF both of these terms, or both of these groupings. We've got an x, both of them do in common, so we pull that x out, giving us x squared plus 4. The second group, we can only pull out a -1, so we pull out a negative sign, and that becomes, that becomes x plus 4. and I goofed up. Does anybody see where I goofed up? Yeah, I wrote down the problem wrong. That should have been an x squared right there. And so my GCF would have been an x squared, and that would have left me, when I take out two x's or an x squared, I'm left with an x plus 4. Thank goodness. Okay, because see, now I've got these common factors, x plus 4 and x plus 4. Now, a lot of people have a difficult time with this because they're like, hold it, what if I pull those x plus 4s? I'm going to write that dummy variable down again. And just say let a equals x plus 4. And so this is like x squared times a minus a. But you do have to remember that, let's write a better looking a than that, that in front of this a is a 1. So when you GCF this and you pull the a out, the common factor, what you're left with, you take the a, you pull it out, you're left with is x squared minus 1. So even if you didn't do a dummy variable, and you just said, I'm going to factor out the x plus 4, when you pull the x plus 4 out, you'd be left with the x squared and the minus 1. And with the dummy variable, I haven't redone my substitution here, but I could just replace that a that I had with x plus 4, so it's the same thing. Now, once again, we aren't done, because we are going to be observant, and we notice I have a difference of two perfect squares. That's an x squared minus a 1 that is squared, so my a is x, my b is 1, and now I can factor everything. I got my x plus 4 and my difference of squares, a minus b, a plus b. And now I have it completely factored. Last example. I put plus and I grab the negative with it. So I have to have a plus sign between them. Okay, this one's got a plus sign in it. Everybody's a plus. So watch how we group this. We go, all right, I'm going to group those first two. And you don't grab, in this case, because it's a positive. Notice how all these, and so I don't have to grab the plus sign. I just leave it there. And there is a plus sign in front of the 9 because 9 is a positive number. We just don't write plus and then another plus next to it. So let's see if we can find a GCF in the first pair here. Looks like we can take a y squared out, leaving us with 3y plus 1. Okay, remember this is a 1y squared, so you leave a spot so that if I were to ever redistribute, that'd be 3y cubed plus y squared, so it has to be equal to it. The second pair here, looks like I can pull a 3 out, so I'm going to take a 3 out, giving me 3y plus 1. My common factor now, here's my first term, here's my second one. They have a common factor, that's the 3y plus 1. So I'm going to pull that out as one number, or one quantity, 3y plus 1, leaving the first term with just a y squared, and the second term with just a 3. I'm going to check to see if I could factor any of these further. I can't here, that's y to the first power. There's a y squared, but it's not a difference of squares because it's a plus sign, and 3 is not a perfect square. So in this case, I'd be finished right there. Okay, so that is factoring when you have 4 terms and you can't combine any of them. And you hope. Sometimes, it rarely happens in practice problems, sometimes you do a GCF like we did here. I erased it by accident. Let's see if I can get it back. There it is. Sometimes you take out your GCF, and you look and the 3y plus 1 doesn't match this, in which case you cannot factor that one. There are some other advanced tricks we could do maybe that would help us out, but sometimes you just can't factor some of these problems, and we've seen that before. So when you're working these problems, because it's just a mix